I almost think I'm gonna change this stuff always to be more like working session or something, and then I should probably change the YouTube title at some point. You know, more to reflect. Is there a way that I can put in like a title is like working session? Working session. Yeah, I don't know. You know, working session or something like that, whatever, something more generic that I can use. And the point is that we're gonna replicate. So we don't have a lot of time as typically happens, but we are gonna at least go to trying to find one very small thing, which is we wait a second, what the fuck did I just do? Didn't that get saved or anything? No, that's okay, it's correct. What am I doing? Yeah, no, that's okay. Spherical integration. Yeah, I was working on these, correct? No, on these. Yeah, and I needed to find that. Yeah, to find the boundaries of Z. Okay. How do we do this? Because we know R, we know theta is 2 pi, but we need the boundaries for these. So we might need some pain. And the function that we have, or not the boundaries, maybe not pain, but actually the whole Desmos thing, yeah? Desmos calculator. So this is the function that we are integrating. What is it? Too many variables. So this is basically x. We're gonna slide it for a. Yeah, so that's what it is. And so we Is there a way that we can cap Z? Or like how does Z evolve? Z being these, right? Is that correct? I think so. I think that's what we're looking for. Because radius is the main variable, alpha is just alpha, and then 2 pi because we're doing the whole circle thing. But yeah, it can be, it doesn't matter where. I think that's always going to be, it never really goes below, so it's positive. I mean, and that's cool because we know it's top 1 and means 0, but that obviously doesn't work. That is just essentially like such a big conceptual fuck up that I had in my head about integrals and stuff like. It's such a basic thing that I'm actually pretty ashamed of it. But yeah, let's so given a, and we're doing this, given an R, because I think that's the idea, right? So we assume a fixed R. Let's say these are. You know, whatever it is, it's like sorry. So you have, so given an R, you know, what are the potential values of Z? So they definitely go, and this is, I'm looking at the function, right? So I'm not looking at, remember, I'm not really looking at the actual wave. So it's at the actual wave function, right? Because remember that essentially, and that's another confusing point. So you have your space, and then it's let's say it's two dimensions, right? So you know, this is R, but then all the points with the same, like these are all, no, what am I doing? So you have the coordinates, and then, you know what, I should be using spherical. I see that already. Fuck. Because all what matters is R for us. So all the points in these center will be the same. You know, all the points. Although it can still be like this. No, it can still be, yeah, it can be still like this. So no, yeah, okay, because they all have the same radius, the same distance to the center. Say that's the center. So you're gonna have that Z symmetry. That's fine. Okay. But then the value is like as a function of what your R is, right? And R can go in many directions. That's kind of the shape the function is going to have. You know that your wave function is going to have this kind of symmetry. So you're going to have a value of Z. For a given position, you have a value of Z that is shared symmetrically, right? So that's why you're doing 2 pi, and that's why you're kind of like going for all the different, say, you know, for the actual circle, right? Because if this is the R is sub 0, that's this one, that's everything that is in this circle. So but first, assuming you have an R, then assuming you have a fixed R, what are the values that you can get as zeta? That's something that's defined in this function, and this is the one we have to use to define the limits, right? That is the trick. That is the trick point here. So how do we do this? How do we do this? What does it say? Like if you have a specific R, right? You have an A. How do you define these? Fuck. I mean, is it really 0 to 1 doesn't work? I know that doesn't work. That will be my first intuition, is like, no matter what R you pick, you're always going to be between 0 and 1 in terms of zeta of Z. Right? This is the example with the example with these. The volume of the sphere, right? So the function you have gives you these already. I guess here, I don't know if what I have to do is I have, because depending on A, but it's always the same. Doesn't really depend on, well, it does depend on A, right? Actually, it does depend on A. That's maybe how you're adding more. It does depend on A, essentially. No. It's between 0 and it's between 0 and these. Right? I mean, that is actually one of the things that happens here, is that Z is something that depends on R, right? So if you pick an R and you pick an A, yeah, so that's essentially, but that's essentially what it is. It feels a bit odd though. Your Z is gonna be exactly that, to be honest. There's no, it's really exactly that. There's no, if you pick an R, it's these. There's no kind of like, maybe I'm just getting some, I'm just getting this wrong, maybe, I don't know. It's just these. That's what's kind of, it's a bit confusing, isn't it? That's definitely confusing. That's definitely confusing. And then once I have these, I say do this and solve for n. Python x2 is got one pi valid syntax. Where have I found? There we go. There's something that's bothering me. What am I doing wrong? I'm not able to translate that basic recipe to an actual practical example. That's what happens often with this crap. Because here you have so here you have this circle. So here you have the since the bounds of z will depend on the value of r, we'll let the innermost integral handle z. That's fine. Well, okay, writing down what it has so far, we get these. So remember, it's important to make sure that order. Yeah, that's fine. For a given value of r, which of the following shows the right range of values for z? Because that's what we're trying to integrate. For a given value of r, be right back. Back there. And that's probably what I'm getting. So this is what we should be looking at. So this is the function we're trying to integrate. Something that is like based on R, it has a certain z value, and then these are the values that kind of grow, I guess, like these, because the higher the r, so you have that kind of conic shape like these, right? I think that is correct. That seems to be at least accurate, because oh god. Let's say, oh god, radius, you know, the radius is against that, say radius, okay, but I mean every point here, right? Like, so every point here has a radius, right? And so this is going to have one z, so that can be the higher, so the smaller is going to have more like these. Yeah, that's fun, because that's z. Yeah, that's it. So, and that's going to be basically this kind of 3D thing like that. So we're trying to get these area in here. Okay, so if you have the area of this thing here. So if you have a given r, is this really the way it is? Is this really the way it's defined? That's why I'm losing my mind. That's why I'm losing my mind in terms of the example here, because this is, we're calculating some specific volume. Here we have this kind of other volume. So z is a function of r, and so basically r is a function of yeah, well, z is a function of r. Oh, man, that is exactly what z is. Give me a z, give me an r, and I'll tell you what the z is, right? But we want to integrate for small for this r, then this is z. For this r, then this is the z, and so forth, right? So it's a specific number. So we don't really need to so we don't really need because in this case z that can go from these values to these values, but then the function is just r. So it's just I mean the function is just 1. That's essentially what you're doing, and you actually kind of, that's the point, I think. The function here is just not, it's really not these, it's really just, it's really just one, and then you have basically this expression here. Does this work actually? That doesn't. This makes absolutely no sense. No. I don't know what I'm doing. I really don't know what I'm doing. That's the point. That's what I'm missing here. Is I'm missing, I don't know how to translate that. That's what's hurting me, because I have no idea how to translate this shit, man. What am I doing? Like, am I doing 2 dimensions? What am I doing? I have a radius. Oh, God. And so, I really, it's zero. It's zero. It's between 0. That's the thing, right? So if I pick a value here, that's the new R. I think that's the problem, is the naming. So that's kind of like, let's say this value, right? That's kind of a given R. So this is between 0, and then I need to kind of get that value. So it really feels like it should be between 0 and then, okay, no, okay, the R, oh, okay, so the R, so let's say if I look at the section, right, the, if this is this R, and then so I need to kind of get these here, so I really need to get these thing here, I think, and that's between 0 and then sort of the e to the minus 2 of like alpha, and then these R prima prima or something like that here. That's what I need to do. I think that's what I need to do. And yeah, and that angle here is what the heck, I don't know. Because I don't know. Because, yo. Or it's just, you know, 0. What do they do here? That's just, oh, but is this theta really? Is this what we're really gonna count as theta? I guess so. We could also do it like that, yeah. Could we? No, we could. In the unit disk. Balancing the integral. What is so much easier? Oh, that's x and y. Okay, I'm looking at it differently. Well, that's not going to depend on the angle, so what are the values of z from this perspective? That's x and y. So that's actually, I will be looking at the thing here and say, cool, so what is, you know, here is like, it does not depend on theta at all, it's just an r. So that's going to be just whatever the r is between 0 and that thing. So it should really be between 0 and that expression, you know, and this is then just R. It should really be something like that, but it is also not. So better luck next time. See you next time. Bye.